Okay, so welcome Algebra 1B students. This is our final lesson on factoring, and we're going to learn a technique called factoring a difference of two squares. And so what we're going to do to begin with is, much like we've done through the entire unit, we're going to start with distributing. What you can see here are a pair of binomials, and the idea of distributing is to allow us to see what pattern emerges, and then of course we will reverse the process, which is to say that we will factor, and that gets us back to this. So right now this would be a factored answer already. We're going to use distribution, the reverse process, just to see what happens, and then in the subsequent examples the idea will be that we will start with an already distributed expression, and we will work back to the parentheses. Okay, and so what we'll do is, if I were to distribute this, if this were a distribution question, then I would use my so-called rainbow, and I'm going to multiply x times x, which is going to give me x squared, x times minus 3, which is going to give me minus 3x, and I'll just change colors here, plus 3 times x, which is going to give me plus 3x, and plus 3 times minus 3, which is going to give me minus 9. And what you're going to notice about these middle two terms is that they are like terms, minus 3x plus 3x, and when we get our final answer, minus 3x plus 3x cancel out. And instead of being left with a trinomial, which is usually what happens, three terms, we are in this case left with a binomial, x squared minus 9, and the middle term drops out. It's cancelled out because the two middle terms cancel each other out. So that is why we call this. So now what we're going to do, like I mentioned before, is the idea is we're going to get this as our question, and we work back to the factored form as the answer. And so this is called a difference of two squares. It's a difference of two squares. Difference because there is a subtraction between the two, and two squares because x squared is a perfect square and 9 is a perfect square. Okay, so again, let's move on, and I'll do another example, and it'll give you an idea of the process. And once more, I'm going to link it to the idea of a trinomial factoring method. So if you were asked to factor x squared minus 16, you could in fact treat this as x squared plus 0x minus 16. So what I've effectively done is added in 0x, which makes no difference because adding in 0 leaves the equation unchanged. But the purpose of doing it this way might be helpful to allow you to see that it results in a trinomial, or I beg your pardon, that it factors in the same way as a trinomial. So if we look at x squared and we say what times what gives us x squared, well, it's got to be x and x. If we look at what times what gives us 16, well, we know that the factors of 16 are 16 times 1, 8 times 2, and 4 times 4. We look at the signs. That is a negative, which tells us that what we need is 1 plus and 1 minus. And then what we're going to attempt to do is look at which pair of factors here are going to add and subtract. So they multiply to give us 16. They're going to add and subtract to give us our middle term, which is 0. And so logically, the ones that are going to add and subtract to give us 0 are the ones that are the same. We put a 4 in both parentheses. We know that the signs are 1 plus and 1 minus. Well, in this case, since parentheses are the same, it doesn't really matter which parenthesis I put them in. Okay, again, if you wanted to check your answer, and this is not a requirement, but if you wanted to check your answer, we could distribute out, and we would get x squared minus 4x plus 4x, which would cancel out, minus 16, and that confirms we would have the correct answer. Okay, so what I'm going to do below is just go through fairly quickly some more examples, and a couple of them are extension examples, so it's worth watching these. At this point as well, you might consider pausing the video and attempting these examples yourself, and then going back and playing the video again to see how many of them you got and or how close you got. Alright, and so what I'm going to do now is you can see from this that there's a distinct pattern that in this case when there's only two terms, or you imagine that there's a 0x term in the middle, we use the x times x, and we always use the factors that are the same as each other. And the other thing we use is 1 plus and 1 minus, and that guarantees that the middle term drops out. Okay, so I'll do this one using just a shortcut method, a slightly more efficient method. So when I see a question like this and I confirm that it's a difference of two squares, and I can do that by looking here, that's a difference, and both of those are perfect squares, you can go basically directly to the answer. It's factors like a trinomial, so we're going to have two binomials. The square root of 9, the factors of 9 that can be multiplied to give us 9 but are the same are 3 and 3. Alternatively, we have 9 and 1, but of course those factors are not the same, so we know we need to use the two that are the same, and we need to ensure that we have 1 plus and 1 minus. Okay, same approach in this question, slightly more difficult because we've added elements of difficulty. In this case we have 4x squared and 25, but keep in mind those are both perfect squares as well. To get 25 we can use 5 times 5. To get 4x squared, since we want the two to be the same, we can use 2x and 2x, and once again it is a difference. Okay, so in this case I'll open two sets of parentheses. To get 4x squared I'm going to do 2x times 2x. To get my 25 I'm going to do 5 times 5. And to make sure I don't get a middle term, a term with an x, I'm going to have the parentheses exactly the same, except one will have a plus and one will have a minus. Again, I'll go through a very quick rainbow just to confirm that this works. 4x squared minus 10x plus 10x minus 25. Middle two drop out and we go back to our original question, and this just confirms that our factorization was correct. Okay. What I'm going to do is I'm going to jump ahead to question D, and question D is slightly different because what we're going to do is we look at it, and you should notice a couple of things. First of all, it's two terms. We do have a minus in between, but 2 is not a perfect square. The only way to get 2 is to do 2 times 1, and those numbers are not the same. So what this seems to indicate is that it's not a difference of two squares question, except if you look carefully at the instruction, there is always the possibility that you need to remove a greatest common factor first. So what I'm going to do is go back to the question and identify if I do have a greatest common factor and remove that first. In this case it's very clear that the GCF is 2, and if I remove the GCF, then that's the same as dividing each of these terms by 2. I will be left with x squared minus 1. If you then look inside those parentheses, x squared is a perfect square, 1 is a perfect square, and there is a minus in between, so inside the parentheses we have a difference of two squares, and that means we leave our 2 outside and we factor the difference of two squares inside. X by x, 1 by 1, 1 plus and 1 minus, and that has been completely and correctly factored. Last question is question C, and watch carefully what happens here. Once again we have only two terms, so the possibility is a difference of two squares. X squared is a perfect square, x times x. 4 is a perfect square, 2 times 2. But this time what we have in the middle is a plus. Now what you will realize very quickly, if we try this in the same way we've done before, is if I use x and x, 2 and 2, the only way to ensure when I multiply 2 times 2 to get my plus 4 I'm going to have to use either a plus times a plus or a minus times a minus. And what I'm going to do is show you very quickly what happens if I use two minuses. The result is x squared minus 2x plus 4. And what you'll see here is that the middle two terms do not cancel each other out, and we end up with x squared minus 4x plus 4, which is not what we started with. And so that indicates that that is incorrect. If I go back and change that to two positives, when I distribute, once again, I will get x squared plus 2x plus 4. And again, I have the same problem. The middle two terms do not cancel each other out. And so that is incorrect. And the third possibility, of course, is if we go and use one as a plus and one as a minus. And the issue with that, of course, is when I multiply to get the last term, I'm going to end up with minus 4, not plus 4. And so this is an example of a sum of two squares. And if you are asked to factor a sum of two squares, the answer is there is no solution, or it cannot be factored. And so in this case, there is nothing for us to do. That is an unfactorable expression. Okay, that is the end of the video. At this point, you should turn your attention to the Khan Academy question sets. You need to do all three of them, starting with the basic, then the intermediate, and then the difficult. The difficult are just questions like D that require that you remove a GCF before you factor the difference of squares.